We want to use our second definition for the trigonometric functions to work some problems. Our first one involves a right triangle. It says triangle ABC is a right triangle with C equal 90 degrees. Find the six trigonometric functions of angle A if side A is 2 and side B is square root 5. So the first thing we want to do is just draw a little picture for reference. So I'm going to draw a little right triangle here. It doesn't have to be accurate. I'm going to label the angles A, B, and I'll make C the right angle. Now what I'm given in this problem is that side A is 2, so side A is opposite angle A, that's 2. Side B is square root 5, that's opposite angle B, so that's square root 5. Then I can find the length of this hypotenuse if I want by saying that C squared, or C is, I'll just say the square root of A squared, which is 5, plus B squared, which is 4. I should say A squared, which is 4, plus B squared, which is 5. When I square those, 4 and 5 is 9. That square root is 3. So that side's going to be 3. Now, my sine of angle A. For angle A, the sine, by my definition 2 for the six trigonometric functions, is the side opposite divided by the hypotenuse. So opposite over hypotenuse, and that will be 2 divided by 3. Cosine of A. The cosine of angle A will be the side adjacent to A divided by the hypotenuse. So the adjacent side divided by the hypotenuse. So that will be square root 5 divided by 3. And then my tangent of A will be the side opposite angle A divided by the hypotenuse. So let me just write down here opposite over hypotenuse, and that will be 2 over square root 5. Then if I want to, I can rationalize this denominator, but again, we don't always do that. Now I want to finish this problem here by going up and finding I have sine, cosine, and tangent. I want to find also cosecant, secant, and cotangent, but to do that I'm just going to use my reciprocal identities. So here cosecant of angle A will be the reciprocal of sine, so 3 divided by 2. Secant of angle A will be the reciprocal of cosine, so 3 over square root 5. And then cotangent of angle A will be the reciprocal of tangent, or square root 5 over 2. Okay, so that's how we use our second definition for the six trigonometric functions to solve for the missing parts in a triangle. Now you have to do the same thing with this definition that you did with the first definition, and that is you have to memorize it. You have to know that the sine of one of the acute angles is always going to be the side opposite divided by the hypotenuse. Cosine is always the side adjacent divided by the hypotenuse, and tangent is always opposite over adjacent. Here's our next problem. I've drawn a diagram over here. You can see I have triangle ABC. C is the right angle. The shortest side here is x. The hypotenuse is 2x. So I recognize this as a 30, 60, 90 right triangle. So this is actually 30 degrees. This is 60 degrees. If this side is x and this side is 2x, then this side is going to be x square root 3, whether I use the Pythagorean theorem or I just notice that this is a 30, 60, 90 right triangle. So I'm going to use my definitions again. Now I want to find the sine of angle A. Here's angle A right here. The sine will be the side opposite divided by the hypotenuse. X square root 3 divided by the hypotenuse, which is 2x. My x's divide out, and I end up with square root 3 over 2. Cosine of angle A, here's my angle A. Cosine will be the side adjacent to angle A divided by the hypotenuse. So I'll have x, that's the adjacent side, divided by 2x, the hypotenuse, and that comes out to be 1/2. For tangent of A, that's going to be the side opposite angle A divided by the side adjacent to angle A. So it will be x square root 3 divided by x. And so I just end up with square root 3. So sine, cosine, and tangent of angle A, just using my basic definition that I have memorized. Now let's go to angle B, because it's also an acute angle, and find the sine of B. The sine of angle B will be the side adjacent to B, which is x divided by the hypotenuse, 2x. So it's x divided by 2x, and that comes out to be 1/2. And I notice that the sine of B is the same as the cosine of A. And that's because A and B happen to be complementary angles. They add up to 90 degrees, and that's my cofunction theorem. The sine of an angle is the cosine of its complement. Let's look at cosine B. Cosine of angle B will be the side adjacent divided by the hypotenuse. So x square root 3 divided by 2x. My x's divide out, and I have square root 3 over 2. And I notice that cosine of B is the same as the sine of A. And A and B add up to 90 degrees. The cosine of one is the sine of the other. Tangent of angle B, here's my angle B. Tangent will be the side opposite divided by the side adjacent. So x divided by x square root 3. And that comes out to be 1 over square root 3. So here I found sine, cosine, and tangent for both of the acute angles in this triangle. I have to find all three sides. Then I just use my basic definitions right here and write these down. And I notice this relationship between cofunctions. Let's look at the next problem. I have the sine of x is the cosine of, and I want to fill in the blank. Well, I know that a trigonometric function and its cofunction, I should say, a trigonometric function of an angle is always the cofunction of the angle's complement. So the complement of x is 90 degrees minus x. So the sine of x is the cosine of 90 degrees minus x, and that's my cofunction theorem. Now, the next thing I want to do is just simplify some expressions using the exact values that we have memorized. First, I want to simplify sine 60 plus cosine 60, all that quantity squared. The sine of 60 degrees is going to be square root 3 over 2. I have that memorized as my exact value. Cosine 60 degrees, 1/2, and I want that squared. Square root 3 over 2 plus 1/2. I'll just add the numerator since the denominators are the same. Square root 3 plus 1 over 2. Now I want to square those, so I'll square root 3 plus 1. Square root 3 squared is 3. Twice their product is 2 square root 3. And then 1 squared is 1. All that's divided by 2 squared, which is 4. So remember, when I square a binomial, it's the first term squared, twice the product of the two terms, that's this term, and then the last term squared. So it's a squared plus 2ab plus b squared. I'll simplify a little more. 3 and 1 is 4, plus 2 square root 3, all divided by 4. I notice that there's a 2 common to the two terms in the numerator. I'll factor that out. I'll have left 2 plus square root 3. When I factor that from the numerator, 4 is the same as 2 times 2. So I have a factor common to the numerator and denominator. Now finally, 2 plus square root 3, all divided by 2. Now, the cameraman loves this when I do this. When I start on a problem right here and write all the way down, he's got to go find it. So anyways, there's kind of a long process, but a good review of some of the concepts you have from algebra and simplifying expressions with square roots. Let's look at our next problem. Secant of 30 degrees. Well, I don't have that one memorized, but I know that secant is the reciprocal of cosine. So I'm going to say secant of 30 is 1 over cosine of 30. And then I have the cosine of 30 degrees memorized. Cosine of 30 degrees is, square root 3 over 2. The reciprocal of square root 3 over 2 is 2 over square root 3. Okay, my next problem, cotangent 45. I don't have that one memorized, but I do know that cotangent is always cosine 45 divided by sine 45. Cosine of 45 is 1 over square root 2. I have that memorized. Sine 45, also 1 over square root 2. Divide this by this, and I end up with 1. So cotangent of 45 turns out to be 1. That will be the same number we'll get for the tangent of 45. So here we have our second definition for the 6 trigonometric functions. It's our right triangle definition. And then because of our 30, 60, 90 triangles and 45, 45, 90 triangles, we've memorized a list of exact values of sine, cosine, and tangent of 30, 45, and 60.